Hey, good morning.
Good morning.
How are you all doing? Is this the earliest class you guys have all semester?
No, I have a class that starts at 6.
What? What is what is that?
It's a military class. So we have
Uh,
to,
all
we
right.
have to be in the gym by 6 a.m.
Okay. Yeah, that's pretty early. I don't actually mind it to be this early, but if I could choose, I probably wouldn't choose the very earliest one. I think most, I mean, some students like you are in even earlier classes, but I think most students would prefer like to be a little bit later. Well, it's just about 8. I think the last I saw, I think there was 6 or 7 students enrolled. So probably wait another minute or two till we get started. And then hi, Cade. Thanks for joining us. I think we met yesterday, right?
Yeah. Hello, good morning.
Good morning. Yeah, I think, let's see, Natalie might be joining us and perhaps at least one more student. So did any of you buy just curious, did any of you buy the textbook from the bookstore? Do you guys usually buy your textbooks from the bookstore, from Amazon, or what do you usually do?
No, I just
I
rented
usually-
mine.
Yeah, I usually rent from Amazon.
Okay, all right. Did you all end up with the 8th edition, or what edition did you end up getting of the textbook?
I got the 8th edition.
Okay. Yeah, I just started using the 8th edition, and I don't think it's very much different than the 7th edition. So we'll see as we go on. I'll talk about that in a moment. But if you haven't bought the textbook, you can probably buy some of the other editions. But the 8th edition is a little unusual. Like I don't think there's actually a hard copy of it. So I think you can only get like loose bound or digital versions. So I don't know. Did any of you get a hard copy, or what was the format of that 8th edition?
I got a hardcover copy.
Okay, I guess I'm just wrong then. So that's good to know. All right, well, it's 8:02. I think this is everyone. There may still be one more person who enrolls later in this class, but at least right now, they are not enrolled. So let's get started today. So today will mostly be introduction to the course. We should get to a couple small problems, back to reintroducing some ideas about calculus that you'll learn in this course. But yeah, let's go through a few slides. So this is, of course, EE 3325 electromagnetics course. I'm Dr. Andrew Chrysler. So this is a little bit about me. I have a bachelor's in chemical engineering from Colorado State University. After graduating from Colorado State University, I moved to Utah I worked as a semiconductor manufacturing engineer for IM Flash Technologies. So I don't know if any of you are from Utah or have family in Utah, but this is that large Micron facility in Lehi on the north end of the Provo Valley. When I moved there, they had recently retrofitted it into this IM Flash Technologies, which was a joint venture between Intel and Micron. That Intel and Micron had wanted to do some work in the NAND flash memory, but that market had already been dominated by mainly, I think, Samsung and Toshiba. So even though they're both pretty big semiconductor manufacturers, they decided to create this joint venture so they could break into that market. And I think it was a pretty good market for some time. However, eventually, I think they continue to try to progress it, and I'm not sure exactly what happened, but the facility eventually returned to being Micron only. And then actually, I believe that entire fab is currently for sale at the moment. So I don't know if that's of interest to any of you. I suspect some of you may be interested in working for Micron or semiconductors in the future, but it's kind of interesting to follow that industry. Because semiconductors are a commodity, a lot of it comes and goes in cycles. So kind of interesting. After I worked there for a few years, I liked living in Utah. I liked living there. I like skiing a lot. So I decided to go to the University of Utah for master's and PhD degrees. And I switched to electrical and computer engineering. So I have did kind of change fields partway through. So if any of you are interested in doing that or changing fields, I'm happy to talk about that. It's definitely possible, and I think it's something that's fun and interesting to do. While I was doing grad school at the University of Utah, I spent a summer in Korea, and I also spent about half a year working at the NASA Glenn Research Center in Cleveland, Ohio. So these are all the places I've lived and worked. After I graduated with my PhD, I worked as a faculty member at Northern Arizona University for a couple years in Flagstaff, which was really nice place to live. When I was working at Northern Arizona University, I was supported this 3+1 dual degree program, which we had with a university in China. So I actually also lived in China. I would teach in China for one semester, then come back, do some work in Flagstaff. So I also have spent quite a bit of time in China. So all this smoke that we're having right now and the very bad air quality is reminding me a lot of being there. So when we lived in China, got to do a lot of fun things. One of the reasons I'm glad that I got a PhD and have taken this career path is, you get to experience a lot of interesting things. They're just some of the stuff we did. We were in China, saw some of their ancient or traditional art. These statues are actually in Luoyang, which was one of the former Chinese capitals. You all may or may not be aware, but Idaho State University actually has a new dual degree program that they are beginning to offer with a university that's actually in this small city, Luoyang. And so this summer I taught the EE 2245 course to those students from the Chinese university. I just taught it online this time, but kind of interesting that we created that course and I visited there. I spent a lot of time traveling around there. When I'm back here in the US, I really like skiing, backcountry skiing. This is me and my wife skiing 25 short in the Teton Park. Also like running a lot. That's what I do the most often outside of class. So these are just some pictures from some runs I did this year. I did ran this Bryce Traverse from the north to the south end of the park. This summer, I did the Bighorn 100-mile race again for the second time. It's kind of fun. You finish right in this river at the very end. So I was just, after a long day of running, just gonna sit down in a nice cold river. It's pretty nice. This was a run I did back home. I grew up in a small town called Longmont, Colorado. This reservoir supplies all of the drinking water for my hometown. This is another run I did this summer. I ran around Mount St. Helens, which was really interesting. This is kind of on the north side. You can see how much vegetation was just, totally blasted away on the north side of that Mount St. Helens. Afterwards, we went and did some skiing on 4th of July, which is always fun, on Mount Adams. Then ran around Oregon coast, and then just some other things this summer. This a couple weeks ago, I did a nice long run in the Sawtooth area, which was fun. Ended up with a nice clear day. So yeah, I just wanted to show you guys these pictures or talk a little bit about this because I just want you to know that I'm outside of class. I have hobbies and things that I like to do, which I'm sure you all like to do. So I'd love to hear about all of your hobbies sometime. And if you ever just want to chat or whatever, during office hours, I'm always open to that kind of thing. And I just want you all to be just a little comfortable and familiar with who I am so that you feel like I'm approachable. So you could come ask me for help with this course or even with, things outside of this course, maybe looking for a job or thinking about different career paths. As I kind of showed you, I've done quite a bit of different things. So that's just a little bit about me. So hopefully we all get to meet in person. I know this course is online, but my office door will be open. We can schedule meetings in person throughout the semester as well, if that's something that you'd like to do or prefer to do. So I actually did not change this course to online due to COVID. I actually just prefer teaching via Zoom. The way that I'm going to run this class is going to be fairly interactive, and I think it's easier when we're actually all on Zoom rather than in those classrooms where we have that separation of the distance learning. However, due to COVID, I did want to mention a couple things. I think probably your other instructors have mentioned this, but we still are dealing with the COVID-19 situation. This Roaring Back website has all of the current Idaho State University guidance there. So if you are trying to figure out what Idaho State University is doing, please go to this website. You can see if you ever are on campus, they will ask you, of course, to wear face covering whenever you are inside. If you have a disability, you can get some exemption. So there's some information about how to contact the disability services. And if you don't do this, I believe they've outlined some disciplinary measures that may happen. I think basically they just want you to treat this seriously. So, and then in general, don't go to campus if you feel ill, but our course is online. But, if you're feeling very ill, of course, I don't need you to be in class, but please just, let me know ahead of time or when you do begin feeling ill. I know that's not always possible, but, communicate to me. And if you do become sick or are having, some kind of medical related trouble due to COVID-19, just contact me and we can work out something. Basically, all of these courses will be interactive, and then like I'm recording this right now, I'll record all of them. And so there will be a recording available later that you can watch for this as well. Okay. And then if you have got vaccinated or not, you can basically go get $100 from Idaho State. So if you want that, I think just go to this link and there's some information about how to do that. Does anyone have any questions about any of this or anything I've said so far? All right. So, all right. So now on to the interesting part or more about this. So this course, as I mentioned, I'm running it online. I'm doing that because I'm teaching this course in this style called flipped classroom. So the flipped classroom style, your homework is to watch video lectures that you can find on YouTube. And then in class, we will solve the homework problem. So typically what the typical setup is going to look like is you will watch videos on your own time before class. Then when we get to, and then you'll watch videos on your own time before class. Then you should take a look at the homework that's posted on Moodle. Take a look at it, see if you can solve it or look through it, see if you can start to understand it. Then in class, you bring the homework problems, and however far you got, if you run into an issue, then between everyone in the class, we choose which homework problem to work on, and then we'll work on the homework problems together. So everyone will be asked to participate in this solution process during class. And so this type of class is going to be pretty interactive. I'm hoping to, speak with all of you, put you in small groups, have you work together, work with all of us. So I can see you all have a laptop, and in order to participate fully, I will ask that you turn on your camera as much as possible, and so that we can all see each other. And this is the reason that I prefer to do it this way rather than in the distance learning classrooms, because in the distance learning classrooms, it's very difficult to see everyone's faces. So if you can turn on your video, I know I sent the email. If you aren't prepared just this moment, that's okay if your video's not on, but I think it'll help us all know that, right, there's a real human right behind the camera, and we're going to be working on problems together, and there's only going to be 6 or 7 of us together in this class. So of course I do understand if you don't have a good situation, but contact me if you feel that you will never be able to have your camera on. Send me a message and we can figure that out, because that'll be fine. But a lot of times in this course, we'll work through, I'll be speaking or working through something, but then I may put you in like a breakout room with one other course member, and in that time, I think it will be very helpful to be able to see each other's face, interact, and feel more like you are in a classroom. And the other reason, the thing that I like about that is, right, if I was teaching this course in these distance learning classrooms, you would not be able to interact in the same way with the people. If you're in Pocatello, you might not be able to interact with people in Idaho Falls the same way, which I am at Idaho Falls faculty, so I spend a lot of time thinking about how to make this better for everyone. So the other thing that has to do with participation, during the class, and you'll see how we do this, I'm going to try to make a comfortable environment where we're all welcome to, share our ideas, our answers, or our solutions. So I'll often ask, who has the answer, or what did you think about this? How did you approach this problem? This type of thing. And if there isn't anyone answering or something, I might need to resort to, what they say is cold calling. I know not everyone is, comfortable with this. So if you aren't comfortable with cold calling, I do understand, but I would ask that if you don't want to be cold called, or kind of like put on the spot like that, I would ask that you send me the work that you've done on the homework prior to the start of each class, so that I know you are still participating in this manner. And so hopefully I won't have to do that. I'm hoping that we can make this a little bit more interactive, and maybe even by the end of class we'll be able to get to doing a little bit of that together. If I do cold call, I'll either ask a student that I think might know, or maybe just use some some MATLAB code to choose a random number. So okay. So the reason that I like the flipped classroom is that you, as a student, you have the opportunity to watch the video, like the theory video, multiple times, and that allows us to focus on solving the harder problems together in class. Also, most of the videos are pretty short, around 5 minutes or less, so it's easier to watch them over and over, or watch them quickly, or break it up into small kind of like bite-sized ideas that help you get one single point across. So in the videos, there's a few different people that you will hear that I've sourced these videos from. Most of them I know or am familiar with. So I've met Dr. Kelly. He's at Bucknell University in Pennsylvania. This is like an undergraduate focused public university. His videos, he's a little bit more theoretical. He has a lot of really good and interesting explanations for some electromagnetic phenomena. Many of the other videos are made by, this was my PhD advisor, Dr. Cynthia Furse, at the University of Utah. And she is one of the first people to take this approach to teaching electromagnetics of the flipped classroom. So she is a real pioneer in this area. The reason that I like teaching using the flipped classroom approach and using Dr. Furse's videos is, right, as you have probably all noticed, right, at least at ISU, most of our faculty are all of the faculty are men. So this gives you the opportunity to have an instructor, a woman that's an instructor as well in this course. So I think that's a good opportunity for you to see and experience that, since we don't actually have anyone on our faculty who is a woman. Some of the videos are also from Sal Khan. I suspect some of you have at least watched his. I'm just always amazed by how good he is and his crew is at making videos that explain complicated things. So yeah, just they're quite great. I know you've all taken Calculus 3, but the first part of this course will be reviewing some calculus ideas that you have all seen at one point, but may have forgotten a little bit over the last year or so. And so I have some videos from the Khan Academy that will help you refresh your ideas about vector calculus. And if you hadn't ever watched them before, perhaps will help you understand them in a new way or a better way. And then, of course, a few of the videos as well are made by myself, and you will see me in course every day. All right, this is the grading criteria for this course. The homework and quiz will all be worth, or each will be worth 10%. The homework and quiz are going to be very closely related to each other. There's, I think, 11 or let's just say a dozen homeworks and a dozen quizzes, approximately one per week. As I mentioned, we'll mostly be working on these homework problems during class. You'll hand them in. And then as sort of a check for yourself, we'll have whenever the homework is due, we will have a quiz that day. And the quiz, you could basically think of it as one, maybe 2 or 3 problems, but usually one problem that's very related to the homework. So it's similar to a homework problem that you've done, or it will cover a concept that you have just learned in the homework. And so this will be an opportunity for you to sit down and have a short amount of time where you solve a problem quickly. So this should, you can think of this as just a check on your homework experience. Did I do enough to understand the homework independently and know it by myself? I like this. I like this approach. I know it takes a little bit more work and it feels like a little bit higher stakes, but what I've always found is that it forces you to think about whether or not you were able to understand everything that you did in the homework. And then there will be these homework and quizzes. The lowest score of each one is dropped. So I know, sometimes you have a bad day, or, you aren't able to get the homework done or understand it quite as well as you want, or, who knows what, right? So there's always something that may come up. So the lowest one of these will be dropped. There is a small participation grade. So as I mentioned, the participation will mostly be, having your video camera on, being in this synchronous online class together. And then when I put you into like breakout rooms or small rooms, or ask you that you're ready, you know what's going on, you aren't gone somewhere else. So that's kind of what the participation grade will be. There is a project that will be later in the semester. I will introduce this in late October. The reason that I've included this project is that many electromagnetic courses at other universities do contain a laboratory component. Not all of them do, but many of them do. And so this project portion is almost like a small substitute for the laboratory. You will be allowed to work on the project independently, or possibly in a team. Probably will depend somewhat on the COVID situation and whether or not you are interested in working with someone else. But the project is pretty fun. It's an open-ended project where you'll get to design a hand-powered, like a hand crank or a hand power generator that turns on an LED light bulb. So you'll get to basically take some of the things that you've learned in electromagnetics and physics and apply it. And then what I think is fun is that the way that that you do this project is that I call it the junkyard generator. So you should be able to find almost everything that you need to do this project. You should be able to find it as something that's trash or salvage or something like that. So you should use something very low cost, or if possible, free items. So if you're able to do it with things that are, totally junk that you found in your junk drawer, if you have one, then you can get bonus points for that. If you have to spend $5 or $10, that's okay too. But the idea is that you spend very little and build something that a little generator. So I think it's kind of a fun project, and then everyone will get to see how other people's generator works. And then the final grading will occur as exams, each one of them worth 20%. So these exams will be on campus. That's the only part of this course that will be on campus, and they'll be at the testing center. So I will ask you later this week to let me know which campus is the one that you are close to and prefer to go to. And I will use that to set up the examinations at the campus that you are close to. So these three will be on campus examinations in a proctored environment. The final grade will then be basically the standard. I don't do the plus or minus grading. I just do the standard breakdown of A, B, C, D, F at those marks. So that is about the grading. Do you have any questions about how the grading works? or how this works? All right.
I have a question.
Yeah.
For the quiz, since it's like opened the day of the class that it starts, is it available like throughout the day or like what's the time frame on that?
Yeah, thanks, Mario. That is a great question. So yeah, let me, I can change what I'm sharing momentarily. So the quiz will open on the Moodle page. I have them set to open at 7:55 a.m. on the day that the homework is due. So I'll bring up the Moodle page and I'll show you. I think yours may look slightly different because I'm still in the instructor view right now. But basically, when you come here and you have the homework, so you can pull up the homework assignment here. This is where the homework submission is going to be. And so you'll submit the homework sometime before 8 a.m. on the day of the class. So anytime basically before class starts, you take the homework, submit it here. And then this quiz will open 5 minutes before the class starts. So this first homework is due on September 2nd. And so you'll hand it in before 8 a.m. and then this quiz will open at 7:55 a.m. And so on that day, on that course day, when the homework is due, you'll have the quiz, it'll open. There will be like a PDF that you can, pull up and it will have a problem. And then you can take a piece of paper, notebook paper, printer paper, whatever, solve the homework problem, take a photo of it and upload it into this quiz submission as a PDF. So it will open at 7:55 a.m. So, a couple minutes before class starts, it will be first available to you. And then it will be due at 8:15 a.m. So you'll have about 20 total minutes to get, to open that quiz up, take a look at the problem, solve the problem, and then take a photo of it and upload it to the Moodle page. And then we'll start class on those days. We'll get class going and everything at 8:20. So that's the way that we'll do the quizzes. Does that answer all of your questions, Mario?
Yes, thank you.
Yeah. So that's the way it will be done. I know it will be a little, since in order to, I don't want this to be too, stressful or anything. So I have on here a practice quiz that I'll give you extra credit for. It's untimed and it's not actually like technical questions or anything, but today after class, if you come down here to this practice quiz, you can pull it up. So this practice quiz will pop up. You can take this practice quiz, right? And the practice quiz is just asking a few questions about the course to help me make sure that I know that you're comfortable with everything that's going on. And then the last question is to ask you what campus you would like to take the exam at. And so you just write this on a piece of paper, take a photo of it, turn it into a PDF and upload it onto the practice quiz. And then submit it just like a normal assignment. So, and this leads me to another good point. So I think do you all have a cell phone? Okay. So there's a couple apps that you can do this with. I like the Cam Scanner app. I don't know if have any of you used that one? Yeah, so the Cam Scanner is a good one. And then there's also another app, just the Acrobat app can also can take a photo and turn it into a PDF. Let's see, looks like I have not signed into Acrobat in a while. But yeah, both of those apps are good ones, and they can be done quite quickly. And then the other app that I would like everyone to use, I should have prepared this a little bit more in advance, but is the Google Drive app. So do you all have that Google Drive app on your phone as well? So later this class, hopefully by the end of this class, we'll get to it, but I have created, you probably all saw, did you see an email where I added you to a Google Drive folder yesterday? You may or may not have seen that, but I added you all to a Google Drive folder. And so that's what we'll use to share the work that we've done in real time. So while we're working on it, let me see if I can share my iPhone. Plug in. Okay, so you can probably see my iPhone now. Let's see, so go to Drive. And when you're in it, I'm sure you probably all have things in your shared drives, but there's these shared drives, and if you refresh it, okay, you can see now this EE3325 shared drive app folder. There's nothing in there right now, but if you just hit this plus button, it will ask you what you want to do. And so you can say, I want to create a new and use the camera. So right now I have camera out. So if we're working in class, right, we could have a problem one, my work, and then you could just take a photo of your work, and then it asks what you want to do. So just say use photo, access to it. Now this is uploaded onto that drive, and you could all see this work in the drive. And so throughout the course, to make this more interactive, there'll be times when I'll ask, hey, can someone upload their work to this shared drive? And so if you have questions on how to do that, you can ask me, or we can look at it later. We'll have some chance to practice this. But the Drive app we'll use during class, and then I recommend using like the Cam Scanner or Acrobat to create the PDFs to upload like your quizzes or your homework to the Moodle page. And so it would also probably be helpful to have the Moodle app on your phone as well. All right. Does anyone have any questions about like the technology or the apps? Okay, we'll have more chances to play around with it, but hopefully that you will all like this format, and we'll have a chance to make it be more like we are all in one classroom together. That's my hope for all of this. Okay. All right, now let me go back to the grading. There's some more details on this. Some of this is a little outdated, but basically your homework, you'll upload that to Moodle, upload it as a PDF. Just make sure that you have your name on there somewhere. It should be tied directly to your name when you submit it on Moodle. So it's really not a big deal what you name your file, because it will be uploaded underneath your name. So it'll be easy for me to keep track of who you are. The exams in person, the testing center, I will give you more information about these, but plan for the exam to be at our normal class period. So 8 to 9:15 I might set it up so it's 9:30 or something, so you have 15 extra minutes. I will give you, I'll set it up so that it's 8 to 9:30, mainly because I don't know if I think the testing center opens at 8, so it may take a few moments for them to get you in there, et cetera. But they will be basically during the exact same time as our class would normally be, with a few extra minutes at the end so that you can make sure that you wrap all the problems up and complete the exam successfully. I have often have used these EE3325 numbers. Hopefully this covers everyone that's in here, but you can attach these numbers to your work. So to make it easier to just keep track of your work. We may not use these too much in this course just because everything will be done via Moodle. So that is the number. The quizzes, covered the quizzes already. They're usually 1 or 2 questions. You'll see what it's like on the first one, but don't, please, these are never going to be pop quizzes. They're always going to be announced in advance. Try not to get too stressed out about them. Basically, if you did the homework and you understand the homework, the quiz is meant to be simple for you. If you didn't do the homework or you didn't understand the homework, the quiz is meant to be difficult. So, if you do the homework, this should be something that is a fairly low stress environment. And then of course one will get dropped for sure, because of the just so who knows why, for whatever reason happens. There's typically no makeup quizzes, and the homework is due on time. So the schedule for this, the first homework is going to be due on Thursday, September 2nd, anytime before 8 a.m. And then that quiz will open on September 2nd at 7:55 a.m. And I've shown you where the links will be. And there's that practice quiz that you can get a little bit of extra credit for that's on Moodle. And you can take that after class anytime you want this week. That one is not timed. That one's just open for you to try it out. I mentioned the project. You can contact me via my email, andrewchrysler@isu.edu. My plan is basically to have like office hours, right after this class. So I will try to keep that time free. Basically, I'll typically have that time free. So if you want to talk with me, a really good time is always going to be right after class. If that doesn't work for you, if you have another class or something, send me an email and we can find a time to meet. If you want to meet in person, just let me know. We can find a way to meet in person. It's much easier for me to meet you in person on the Idaho Falls campus. Are any of you actually typically go to the Idaho Falls campus?
I do.
Okay, so Cade, if you want to meet me in Idaho Falls, that's for any reason, that's very easy to do. For those of you in Pocatello, I will probably be like, I have other like grad students in Pocatello and things like that. So I do go to Pocatello, not all the time, but probably something like 2 to 4 times per month I'm in Pocatello. So if you want to see me in Pocatello, the best thing to do is to email me at the beginning of the week or something and say, hey, will you be in Pocatello this day? And could I meet you in person at your office? And I will let you know what my current plan for the week is. So I'm totally fine with meeting in person if that's something that is more comfortable or more convenient for you. But it's always, it's very easy to meet me via Zoom. Just send me an email. We can find a time to meet. And these ones are going to be the best time is just right after class. So do any of you have a class right after this one? All right, perfect. So it seems like that's a good time to keep this office hour at. Okay, yeah, before we started, we were speaking about the textbook. It sounds like you can get this in a hard copy, so that's awesome. I prefer hard copy textbooks. From what I could gather, what they basically did was they updated some of the figures and some of these learning modules. The learning modules, I know some books have them and they aren't that great. This one has some pretty cool learning modules that we will definitely be using. They're like online Java applets that help you visualize some of the electromagnetic phenomena we'll be discussing. So we'll certainly use some of the apps, and whether you have the 8th edition, 7th edition, or anyone before that, you can still download the apps, the web apps online. I've never met Fawaz Ulubi, but I've emailed him a few times, and my PhD advisor has written another textbook with him. He has a really cool approach to learning. He actually has released a circuits book that's totally free, and so he's a pretty big fan of low cost or open source learning materials, and so he has some good stuff on his website that we'll be using. So this is the one that I think the bookstore says, go for the 8th edition. However, this one is totally fine. A lot of my work from previous iterations of this is based on the 7th edition. I believe that the 7th and 8th edition chapters line up completely with almost no changes. So this one is totally fine to purchase as well if you want to purchase a textbook. And then there are more differences, but you are welcome to go with the 6th edition or 5th edition. You will probably have to the chapters might not line up between the 6th, 5th, and 6th, but the material is pretty similar. So if you're someone who likes to save money by taking the old editions, I think these ones generally work pretty well. So that's the story on that. And honestly, I will probably be using this one mostly, although I also have access to this one and we'll use it. So if there's some difference or you don't have it, I will photocopy, or I'll make everything that you need for this course. I will make it available for you in some way. So all right, and then we'll use this companion website occasionally. This link will be in the homework assignment later, but there's some useful things on the companion website, like those web apps. When you're doing quizzes and exams, make sure you have a real calculator, not a cell phone. So for one, these are more powerful, but for two, these are not networked devices. So make sure you have a normal calculator. I use this calculator, the TI-89. So I don't know if some professors have restrictions on the calculator you use, but I recommend this one. It's a lot more powerful than these ones, even though these ones are allowed on the FE. I think you can do more powerful problems with something like TI-89. In class, each day, I recommend you have each one of these prepared, some paper or a notebook, so that if you do some work, you can take the photo. Calculator, so you can crunch any numbers that you need to, and some Zoom machine so that you can access the interactive part. This is the approximate schedule. We have the 16 weeks, plus 1 week of no class, and then 1 week with the final exam and the project. We will start out in this course by first, we will cover, we'll review a bunch of vector calculus. So some things that you've done before, we'll review that, because we'll use vector calculus a lot in this course, because we're dealing with fields. So when I say fields, that's things like electric field, magnetic field. We're dealing with fields. Vector calculus is very useful for dealing with fields. And it's useful to get a nice review on that vector calculus. So we'll spend about 2 weeks reviewing vector calculus, at least 3 days. Then we'll go into
Quick
electrostatics. Yeah, go ahead.
So working on the project, would that be something we just do on our own, or is that like want updates on our progress as we?
Yeah, the project.
Yes.
Yeah, the project will be announced this week, week 10, and it will be that the generator project, building something that a hand-powered generator that can power an LED light bulb. And so that's basically going to be a application of Faraday's law. Okay, so that's the reason that we'll do it around week 10. The project, you will have the option, depending on what you're comfortable with, to do it independently by yourself, or if you are interested in meeting with someone else in person and doing it with another person, that will also be okay. Does that answer your question?
Yes. And I wanted to know if once we decide what project we're working on or how we're doing it, do you want updates, or we just get the project and just turn it in?
Yes. Okay. Yeah. Great question. Yeah. So there will be the intro to the project on this week, and there will be one class period. Let me see here. Let me share the more detailed schedule. So I have the first class period after the fall break. This will be there won't be a normal class. This will be each team that is working on a project will need to schedule a meeting with me so that I can get an update on how much progress you've made in 4 weeks. Okay, so there will be one week of required that you do have to update me. We'll speak much more about all of this in detail once we get to this week 10. So once we get into this, the electromagnetics, where we're looking at the complete time varied field, there will be more information, but you will have the project, and there will be one project status meeting that you must have with me. So that will be part of the requirement, is that you each person or each team does meet with me at least once. Mostly last year, I think there's a few people who waited a little bit too long, and so this is just to force you to have something done by that meeting where you can tell me, like, this is my exact plan. Okay, so I think that it's designed to help you make sure that you're on track. I won't be requiring nearly as much as, like, senior design. Like, there's, you don't need a Gantt chart or something like that. So, okay. But we'll cover more about the project in more detail. Like, I'll probably spend 30 minutes or something at least in late October, if not longer, speaking about how the project will work. So any other questions? And that detailed schedule is also available on Moodle. This is just sort of the big overview that I wanted you to see. So the big overview is, first we review, then we do electrostatics, then we do exam 1. Then we go into magnetostatics. So static, right? We're just going to be talking about things that are not changing. And then we go into chapter 6, and this is when we put it all together and do time varied fields. So this is kind of like when we finally get to what real life EM is often like. So then after that, we do exam 2. And then in the very end, we'll do transmission lines. And so transmission lines are basically when you have an electromagnetic field, it can be contained in certain physical structures. And those physical structures we often call transmission lines. You're probably familiar, the one that you're probably most familiar with is the coaxial cable, right? So if you have cable TV, you have that coaxial cable that you plug in, and That's a special type of transmission line. It has an inner conductor and an outer conductor. And there's a lot of details about how waves can propagate on those kinds of guided transmission lines. And so that's, to me, this is the stuff that I like the most, because this is what I've done. This type of work is what most RF engineers and people who work in the field and do applied electromagnetics, they're typically dealing with things related to Smith charts, wave equations, transmission lines. So I find this part to be the most interesting and the most applied. And you'll probably see that I'm the most excited about this part too. So, so that'll be fun. And then the last week, the final exam, I believe it's at 7:30 a.m. on Monday. That first day of the finals week is what the ISU schedule says. Okay, one last thing. The first exam will cover material from this section. Exam 2 will cover material from this section. And then the final exam will be, approximately, let's say 2/3 material from this section, and then 1/3 material from this. So the final exam will be cumulative, but it will mainly be a test on these items. So let's say, it'll be mostly questions from here, and then probably like one question from here and one question from here, something like that. So the final exam is cumulative, but exam 1 and exam 2 are on just the previous materials. All right, so that, took a little bit, but that's the overview of the course. You have any questions? Feel good about what's going on? All right, let's do a little bit of vector calculus then. Maybe get a chance to practice using some of the technology as well. All right, so this chapter 3 is on vector analysis, and a lot of it's going to just be review of things that you have done before, but we'll be using them like a lot throughout this course. So just want to make sure that we're all on the same page and ready to use it. We'll look probably through section 3.1, 3.2, 3.3 this week, and then these ones the next week. The way you should prepare for this is, let's see here, go to Google Chrome. So I have the Moodle page arranged by homework assignments. When you go into the Moodle page, you can find the homework 1 here. So open it up. These are the problems. We'll work through these in class. In order to approach these problems, you should watch the videos here. I have 2 different sets of links. This one is the MP4 files. So if you, for some reason, want to download the video ahead of time, you could use the MP4 file here, or you can open up this PDF, which is a link to the YouTube video where the video is stored. So depending on what works better for you, you could use the links or the MP4s here. If for some reason you have a really bad internet connection or something like that, and you need all of the MP4s in advance, please let me know, and we could meet, and you could get maybe like a flash drive with all of this on it or something like that. But I suspect, since we're all in here using Zoom, that the YouTube link will probably work best for all of you. Okay, so going back to the work, so we'll work on these. You can see that the videos, they relate to the chapter sections here. So you can see what the video is, watch those ahead of time. And the first set of videos you should watch before Thursday, so that on Thursday we can just get straight into working on homework problems. Okay. So this week we're going to refresh our memory of vectors and coordinate systems and do some calculus practice in different coordinate systems. So those videos you can find on Moodle, like I just showed you. Okay, so take a minute now. So as we get started, and just think about these different things. Do you remember what a vector is? And what is the difference between a vector and a unit vector? And do you remember the magnitude of a vector? And what is the magnitude of the unit vector? So take a minute and think about these questions. So does anyone have a working definition of vector that they like to use?
Vector has magnitude and direction.
Yeah, exactly. It has magnitude and direction. And what makes a unit vector different than a vector?
Aren't the unit vectors just the JK and I, which mean it has only one unit place and the others are 0?
Yeah, and you can have, you could create, if you have another vector and you change your coordinate system, the unit vector does not have to be just JK and I. It could be, but it does have a magnitude of 1. And how, do you remember how to find the magnitude of a vector? This one's a little more complicated. This one, you'll square each component and then take the root of all of it to find the magnitude of it. And the magnitude of those unit vectors is 1. So that's probably all review from maybe a few classes you've talked about them. In this class, we will use, well, every class, right? There's a lot of different notations for vectors. Physicists do it one way, mathematicians do it another way. Electromagnetics, because we're using vectors, we'll use our own approach. And what will ask you to do is do it in this way. Okay, so whenever we work in this class, please use this notation. This will just make it easier to see that you're following along, but also because this is the notation that we like to use to help me understand that you are following along. So when you look in the textbook, you'll see that the vector is bold, but of course that's kind of hard to do when you're writing by hand. So when we write it by hand, just take the vector and put this arrow on top of it. And when we're writing by hand, this will be the magnitude. It'll be the vector, but without the arrow on top. And then we will reserve this hat for the unit vector notation. Okay, so the laws of vector algebra, you probably remember all of these. And let's see here. So we have the vector, and you can see that this is in bold here. So when we write this, right, I'll write this A. And you could write it this way or this way, where this is the magnitude, right, of the vector A, or we could write the magnitude as just this scalar A. A vector like this one, right, has components, X, Y, Z components. So this is in the Cartesian coordinates. And we have this X unit vector, Y unit vector, and Z unit vector. So let's see, was it, Calvin called it IJK. In this course, we'll use X, Y, and Z. Because we're electrical engineers, we often avoid using I for anything besides current, and then J, of course, is what we use for the imaginary number. So the IJK is a little tough for us electrical engineers to use. So we'll use the XYZ here. And we'll put these hats there to say, okay, this is the X direction. This is the magnitude in the X, magnitude in Y, magnitude in Z. We can find the magnitude of the full direction using this squared, root of all these squared. And then the unit vector, we could make a unit vector A of some vector A, right? So this vector has direction and magnitude. And we could find the unit vector of it by taking the vector and dividing by that magnitude. Okay. So these, right, these are the base vectors X, Y, and Z. And they are all, our base vectors are unit vectors, but the base vectors are in the three cardinal directions for the Cartesian coordinate system. We'll also speak later about the cylindrical and the spherical. So we'll use all of these coordinate systems extensively throughout this class. So one of the key skills we'll be learning this week is how to convert between these and just getting comfortable with using all three of the different coordinate systems. So for Cartesian, we have these base vectors, and we have slightly different ones for cylindrical and spherical. Okay, so how about you give this a try? Yeah, a few more minutes. So if you have, take a moment, see if you can find a piece of paper or a notebook. See if you can write what are AX, AY, and AZ. So basically, what is the magnitude in the X direction, magnitude in the Y direction, and magnitude in the Z direction? What is A, the magnitude? What is the magnitude of that vector A? And what is the unit vector? So see if you can do this on a piece of paper. Once you're finished, if you have that Google Drive app, see if you can just upload a photo of your work into the Google Drive app. So I'll just give you a few moments to work on this now.
I lost the question.
Yeah, okay, so you have this vector A.
See it now, I couldn't see it.
Oh, okay. Yeah. Wait, so yeah, okay, never mind.
Okay, and how are we, or what are we supposed to name it as we upload it again? Sorry.
Oh, when we're doing this work in class, don't worry about it because it'll show me the name of the user that uploaded it. So,
Okay.
some of those naming conventions that I had, I was using when it was like more in person. And also I've taught this, when I taught this in China, there was like over 100 students. And so I got really confused about whose work was which. So that was the other reason that I had some of those in there. Then let me know too when you do have something uploaded.
Okay, I uploaded mine, I guess.
All right, let me take a look. Okay. All right, yeah, see Calvin and Daniel's in there. Okay, so I'm hopefully I'm gonna end this slideshow. So just for now, and so we can look at this in the last 5 minutes. The slides are available on the Moodle page if you want to take a look at them. But I'm gonna show you. For some reason, I apologize. I'm trying to open this PowerPoint, which I will write some notes on, but it is only going into full screen mode, and I'm not sure why. Okay. All right, so do you see this that says date 8/24?
Yeah.
Point, okay. All right, I'm not sure what was going on, but this is what I will do, what we'll do a lot during class. So I can see Calvin's work here. So I'll just pull it from the Google Drive onto here. And now we can look at the work. So this is Calvin's work on the problem. And this is the problem itself. So we were given this problem, and then we have Calvin's work here. So let's take a look at it together as a class. So what are the magnitude ax, ay, and az? So Calvin has 1, 2, and -3. Does everyone else agree with that, or is there any disagreement? Anyone else think he's correct?
That's
Yeah.
what I have.
Yeah, so yeah, that's what this should be, right? So AX, right? We could write this, we don't see it, right? But this is X is the magnitude of 1. It's basically unwritten. The Y magnitude is 2, and then the Z magnitude is 3, but it is in the negative direction, right? So we have 1, 2, minus 3. So, right, great job. All right, so what about the magnitude of A? Did you all get root 14 as the magnitude of A?
Yeah.
Yeah, and so we see this, right? This is 2 squared, and right, 3 squared is equal to 9, right? So this should be the correct magnitude. And then the unit vector, right, is the x hat, the full vector, right? It's the vector A divided by the magnitude. Okay, so this is how we'll do a lot of the homework problems in class, right? We'll have a chance, we'll work on them together. You might upload some of your work. I'll just choose one out of our shared drive, pull it into this set of notes, and then we'll annotate it together, right? So we'll basically all be working on the homework problems together. So I hope you can see how this will be interactive and why I would like you to have your video on so that we can speak with each other, talk about what we're seeing together. And some of the times too, I'll put you into breakout rooms like on a problem. So maybe 2 of you could work on the problem together and get a little more interaction that way. And that'll just be with a random other student in the class. And then this template, right? So I wrote some notes on here, right? And so these notes at the end of the day, whatever notes we take in class, I will later upload this. I'll just take it and I'll upload it into the Moodle page onto this section that says daily notes. Okay, and so that section, class notes, I apologize. So into this class notes section, I will upload the whatever notes that I write during the class, I'll upload them into this class notes area. So you'll have those all available to you later. There's links to the old class recordings up here. If for some, the course, doesn't change too much, you can always go back, look at them. I'm going to add another link to the courses for this semester. I'll put another link on here. You can find the syllabus, the schedule, the syllabus. We basically covered that all today. The schedule shouldn't change too much, and there'll just be some other useful things up here. So so I think class is over. You're welcome to leave. If you have any other questions, I'll stick around for however long it takes. We can talk about the class or any concerns that you have, but otherwise you're free to leave. And if you have any questions, just feel free to stick around.
Thank you.
Yep, you're welcome. Have a nice day.
Thank you.
Yeah.
A quick question. How would we be using the textbook?
How will you be using it?
Yeah.
Yeah, that is a good question. I think so. Most of the theory is going to be covered in the videos and online. But the theory, all of the videos that I have, like they're teaching the theory directly out of the textbook. So sometimes if you still have questions or, want to see the original figure or understand better, it may be useful to go and read in that textbook. So I'm not comfortable saying the textbook is not required because I think it is very helpful. But it's not, I'm not going to, it's assigned in the sense of we're going to be working like directly out of this textbook as we go. Does that answer the question? I think you might have gone on mute on accident.
I asked because I think there was 3 listed and I was kind of confused on if I should get everything or just one.
Yeah, I see. Yeah, do you mean 3 in the bookstore or 3 that I showed you?
that you showed, like in the
Yeah.
course, it shows us like textbook required, and for this class, at least like 3 texts
Yeah, at the bookstore or
online. Like when I go to the class for the detailed schedule, it shows me like.
yeah. I think you might have gone on mute again, but do you happen to have it pulled
Let
up?
me check it. Yeah, let me check it. So let me see if I can pull it up.
Because I'll also pull up what I think you might be seeing and try to explain why it's this way.
Sorry, it's taking time.
Yeah. I also was very confused about this. I think what you're seeing is what I was seeing, which is that this textbook is in like 3 different formats. One is digital, one is like loose, and one is bound. And I believe they're all the same thing. So, and that specifically applies to this edition. This edition has several different versions that, as far as I know, are all the same. And that's what the bookstore told me.
Okay.
But I was,
Yeah,
I was
because
very confused.
I had the option to like get everything,
Mhm.
which I thought was that's why I held on and didn't get it, because I was
Okay.
like, they look the same, like the name is the same. So I wanted to be sure before I did that.
Yeah, and that's fine. I think you will use, if you have the textbook, you'll end up using it this semester, but you don't need all 3.
Okay.
And it's confusing too, because I think if you go, it's very confusing because on Amazon, right, it says like this isn't available, which is just weird, right? Like almost that's not normal for Amazon. And it's because there's all these different versions of it. But if
Yeah.
this version, wow, even this version is expensive. But
Yeah, like the one sold by the university is actually like cheaper.
yeah,
But I was just worried because some of the ones on the university's website has like different producers.
yeah,
So I didn't want to make the wrong call.
yeah. I think any one of those 3 will work depending on what your preference for it being bound or loose or online. Yeah.
That's what I wanted to.
Yeah. Oh, and then this one too. This one would be helpful, right? And this one's like $20 if you just wanted to buy this one. I think trying to remember, it's been a while. Let's see if I have a copy of that here. I'm not sure I have a copy of this one, but it's pretty similar as well.
Okay.
But if you have the opportunity to buy the newest one, and it's pretty cheap, I think that one is the one that would be the most helpful. So,
Great. Thank you very much.
yep, you're welcome. Have a nice day.
You too.
Anything else?
No, that'll be all.
Okay. All right. See ya.
See ya.